Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this lesson is regarding trigonometry past papers questions. So the first question that we have is from Winter 2021, paper 1, variant 1, and it is question number 3 in the paper and for 4 marks. So the question says solve by factorization the equation 6 cos theta tan theta minus 3 cos theta plus 4 tan theta minus 2 equals 0. So here I can see we have cos theta, tan theta in the equation. So this equation directly cannot be solved. We have to factorize the equation to obtain one trigonometric function, the value for one trigonometric function. So let's start solving the question, and the domain also that is given here is from 0 to 180 degrees, meaning we have to consider the first and the second quadrant only. So we have 6 cos theta tan theta minus 3 cos theta plus 4 tan theta minus 2, this is equals to 0. We have 4 terms in the bracket in this equation. Therefore, I shall be grouping the first 2 terms and the third and the fourth term. And then from here, from the first 2 terms that I have underlined, I can take 3 cos theta common. So 3 cos theta common, I will be left here with 2 tan theta and a minus 1. From the last 2 terms, I can take a positive 2 common, so that here I'll be left with 2 tan theta and a minus 1, which shall be equal to 0. So here I can see I have 2 brackets. One is for 3 cos theta plus 2, and the other is for 2 tan theta minus 1, and this shall be equal to 0. So I can say that it's 3 cos theta plus 2, which is equals to 0, and I have 2 tan theta minus 1, which also equals a 0. So cos theta then shall be equal to negative 2 divided by 3. Our domain here is from 0 till 180 degrees. Therefore, considering the first 2 quadrants, I should say that cosine is negative in the second quadrant here. Therefore, I should be getting the basic angle in the second quadrant. So the basic angle then is, I've located the quadrant. Now I shall be getting the basic angle for cos inverse 2 by 3 in the degree mode. So this basic angle, it comes out to be, so the basic angle in the second quadrant comes out to be 48.189, or I can say that the theta value here then is going to be 180, the general angle, minus 48.189, and this answer shall be 131.811. And we know that the theta value has to be taken up to one decimal place. Therefore, this is 131.8 degrees. So this is one of the angle with respect to the cosine theta that I should be having here. Now, solving for 2 tan theta minus 1, which equals a 0, I can say that it's tan theta, which is equals to a 1 by 2. And locating the quadrant, first and the second within the domain 0 to 180 degrees, tan theta is positive in the first quadrant. Therefore, it's going to be this angle here. And I can say that the theta angle here is going to be 26.565 degrees, or taking up to one decimal place, I can say that this theta angle here is a 26.6 degrees. Therefore, the answer that I should be having for this question is going to be for theta, which is equals to 26.6 degrees and also 131.8 degrees. So this was a very simple question taken. So the second question is chosen from Winter 21, and it's paper 1 variant 3 and question 7th in the paper. Part A, show that the equation tan of x plus cos of x divided by tan x minus cos x equals k, where k is a constant, and this can be expressed as k plus 1 sine square x plus k minus 1 sine x minus k plus 1, which is equals to 0. So here in the given equation, it was tan of x and cos of x. So I should know that tan of x should be replaced by sin x over cos x to get the equation entirely in sine form. So tan of x equals sin of x. So in the given equation, I am saying it's tan of x plus cos of x, which can get equal to k times tan x minus cos x. Tan of x can be replaced by sin x over cos x. So sin x over cos x plus cos x equals k times sin x over cos x minus cos x. Then I can take the LCM. So taking the LCM, this becomes sin of x plus cos square x divided by cos x, which is equals to k times sin x minus cos square x divided by cos of x, which is the LCM here. So if I look at both the sides, then I can see that in the denominators, I have the same trigonometric function cos of x, which can get simplified. And here I will be left with sin x plus cos square x, which equals k times sin x minus cos square x. The required equation should be all in terms of sine. Therefore, in place of cos square x, I can just have the identity, which is 1 minus sin square x, cos square x replaced by 1 minus sin square x. Here also cos square x is 1 minus sin square x. So if I simplify this equation, it becomes sin x plus 1 minus sin square x, which is equals to k times sin of x minus k times 1 minus sin square x. Solving further, sin x plus 1 minus sin square x is equals to k sin x minus k times 1 negative k minus minus plus k sin square x. So the required equation wants k plus 1 sin square x. So I do have a k sin square x here. I'll be taking the entire terms, all the terms on the left side to the right side, so that this becomes k sin square x plus sin square x, k plus k sine of x minus sine x, and then I have a minus k and a minus 1, which then will be equal to 0. Taking sine square x common, I'll be left with k plus 1. Taking sine x common, I'll be left with k minus 1, and then negative common from here, I'll be left with k plus 1, which is equals to 0. And this is the required form, and we have obtained the equation here, and this is shown. Now, part 2 of the question. Part 2 of the question says, hence solve the equation tan of x plus cos of x over tan x minus cos x equals 4 for 0 to 360 degrees. Initially in part A, this left side was equal to k. So now if it is given as a 4, then it means that k value here is taken as a 4. That means to solve the equation, we have been given the k value. We can substitute the k value here, and I can say it's 5 sine square x plus 4 minus 1, 3 sine of x, and a minus 4 plus 1, 5, which is equals to 0. Now, it's a quadratic disguised equation in terms of sin x. Therefore, I can assume m as a sin x, and therefore m square is sin square x. Our quadratic equation becomes 5m square plus 3m minus 5 is equal to 0. Solving the equation, my m value is equal to negative 1.344 and also 0.744. M is actually equal to x. So sine of x equals negative 1.344 and 0.744. If I equate sine of x to negative 1.344, I can see that this is the value which is less than 1. Sine has to be within negative 1 and 1. Therefore, this value is not possible. Sine of this value is not possible. So I shall be equating sine of x to 0.744. It's a positive. The domain given to us is from 0 to 360 degrees, all 4 quadrants. So locating the 2 quadrants for positive sine of x, it should be the first quadrant and the second quadrant. So next step is to get the basic angle, which comes out to be sine inverse 0.744, which is a 48.07. Basic angle on in both the quadrants is a 48.07. Therefore, the general angle x then shall be equal to 48.07 and 180 minus 48.07, or I can say it's x, which is equals to 48.07 and 131.93, or rounding it off up to one decimal place, this becomes 48.1 degrees and 131.9 degrees. So just make sure that all the angle values, they are represented up to one decimal place unless and until stated something else in the question. Let's move to the next question. Question 3, and this is from Summer 21 and paper 1 variant 1, and the question says, the diagram shows part of the graph of y equals a tan x minus b plus c. Given that it's 0 less than b less than pi, our b value here is between 0 and pi. We need to state the values of the constants a, b, and c. And this is for 3 marks. So here for a, b, and c, I should be knowing the transformations. And we know that transformation for b is going to be the translation along the x-axis, and this needs to be a positive translation along the x-axis, because we know for x-axis translations we have to change the sign for the value here. So it has to move by positive b and a 0. This positive c is vertical translation, and a here is the stretch along the y-axis. So these are the three transformations that are taking place here. So let's start analyzing the given graph here. So if we analyze the given graph, what we can see here is that at 3 pi by 4 and then at 7 pi by 4, these values here, they have been translated to be asymptotic. They have been translated along the x-axis to be asymptotic, meaning we know that it's tan of pi by 2 and also tan of 3 pi by 2, which is equal to infinity, or it is undefined. So instead of 3 pi by 2 and tan pi by 2, we can see that these undefined values, they are at 3 pi by 4, meaning from pi by 2 it has been translated to 3 pi by 4, and then from 3 pi by 2 they have been translated by 7 pi by 4. And what we see here is that they have been translated by positive pi by 4 here. Here also I can see the translation, which is a positive pi by 4. So the value of b from this graph is very much obvious, and I know here that b value shall be a pi by 4. Next is to get the value of a and the value of c. So again, we have to analyze the graph. So if we analyze the graph here, we know that in the first quadrant, the tan graph, it has a period of 180 degrees and it covers two quadrants only. So quadrants, two quadrants, and then having a period of 180 degrees or a pi radian. So if we look at the graph, then I can see that the positive values in the first quadrant, and I'm already saying that the graph has been translated by pi by 4, meaning 0 value here has been translated to a pi by 4 also. So if this is translated to a pi by 4, then what I can see here is that this graph here is a positive, and on the other side, from the same value, which is a 1, I can see that this graph here is also a negative, meaning this is how the cycle of the graph is getting completed. It's a positive here, positive here, it's a positive here in the first quadrant translated by pi by 4. This is my first quadrant, and then this value here, this is a negative, and the cycle is now getting completed here. So if the cycle gets completed here, what I have seen here is that it's actually this one, which is going to be the mid-axis value. This is the mid-axis value. Therefore, another thing which is very much evident from this graph is that C value here is a 1. So if C value is a 1, now the only thing that is left to get the value of A is I have my B, I have my C, And with respect to a and b, I can just look at the value which is giving me a definite value here. So another definite value that I can see here is this value, which is a 3. I can see here that when your x is a pi by 2, our y value is a 3. So I'll do some simple working here. When x is a pi by 2, y value here is a 3, and they have said that it's y which is equals to a tan of x minus b plus c. I have found the value of b, I have found the value of c as well. Therefore, now I can substitute y with a 3. A is what we need to find out. Tan of x is substituted by pi by 2, and then I have the b value, which is a 4, and then I got c as well, which is a 1. So here I can say it's a 3 minus 1, which is equals to a tan pi by 4. Tan pi by 4 is a 1. 3 minus 1 is a 2. So it's a times 1 here. Therefore, simply I can say that the a value here is a 2. So this is how I will be completing this question. And just to check, what I can see here is that it's y now, which shall be equal to substituting a by 2. Then I have tan and x minus pi by 4. And then I have the c value, which is a 1. So simply just substitute any of the given value here. Like I can substitute 3 pi by 2. I can take x as a 3 pi by 2, and from the graph I can see that when x is a 3 pi by 2, the y value here is a 3. So y value here is a 3 then. So let's check if our two sides are getting verified. Y equals 3. It's 2 tan x is 3 pi by 2 minus pi by 4, and then I have a plus 1. This will give me 3 equals 2 tan 5 pi by 4 and a plus 1. 5 pi by 4 is a positive 1. It's the third quadrant, so it's a positive 1 and then a 1. And I can see here that 3 is equals to 3. I have also verified the equation. Therefore, I can simply say that in this question, my y in terms of a, b, and c shall be 2 tan x minus pi by 4 and then a plus 1. So this is how this simple question can be done with respect to the transformations that we have discussed in the previous videos. So question 4, that this question has been taken from Summer 21, paper 1, variant 1, and it's question 7. Part A, prove the identity 1 minus 2 sine square theta over 1 minus sine square theta equals 1 minus tan square theta. So we have to prove this identity where they are saying it's 1 minus 2 sine square theta divided by 1 minus sine square theta, and this shall be equal to 1 minus tan square theta. So I will be starting my work from the left hand side, and here I will be having few identities. Number 1, it's sine square theta plus cos square theta. This is equal to a 1. And number 2, I can say it's cos square theta, which then shall be equal to 1 minus sine square theta. So I will be using both these identities in place of 1. In place of 1 here, I shall be writing sine square theta plus cos square theta. So this is sine square theta plus cos square theta minus 2 sine square theta divided by 1 minus sine square theta, which is obviously a cos square theta. So it should be a cos square theta. Sine square theta minus 2 sine square theta is a minus sine square theta, and this whole is divided by cos square theta. We know very well that tan theta is equal to sine theta over cos theta. Therefore, tan square theta shall be equal to sine square theta over cos square theta. So let's start working. I can divide each and every term by cos square theta. And if I do that, this becomes a cos square theta over cos square theta minus sine square theta over cos square theta. And further, I can say this is 1 minus tan square theta. And I have just come to the conclusion that left hand side is equal to the right hand side, and therefore it is proved. So part B says, hence solve the equation 1 minus 2 sine square theta over 1 minus sine square theta, which is equals to 2 tan to the power 4 theta, and the domain is from 0 to 180 degrees. So here again I can see it's a sine square on the left side and a tan to the power 4 on the right side, and we know that we have to have the equation at least in one trigonometric form to solve the equation. So in part 1, hence means you have to have the result from part 1, and from part 1 I can say it's 1 minus 2 sine square theta over 1 minus sine square theta. We proved this to be a 1 minus tan square theta. So just writing 1 minus tan square theta in place of 1 minus 2 sine square theta, in from this is coming from part A. 1 minus 2 sine square theta divided by 1 minus sine square theta. In part A, we showed that this was equal to 1 minus tan square theta. So I can substitute 1 minus tan square theta on the left side so that my equation becomes 1 minus tan square theta, which is equals to 2 tan to the power 4 theta. And we know the domain, it's from 0 to 180 degrees. So 2 tan to the power 4 theta plus tan square theta and a minus 1 then will be equal to 0. So again I can see that it's a complex disguised quadratic equation where I can say that let m equals tan square theta, and therefore our m square will become tan to the power 4 theta. So if I substitute m and m square, I will be getting 2m to the power square plus m minus 1, which is equal to a 0. So this means I can just solve the equation to get the values of m, and the values of them m shall be, so the value of m that I can have from this equation is a 0.5 and also a negative 1. We know m was substituted for tan square theta. Therefore, tan square theta is a 0.5 and tan square theta is also equal to a negative 1. So it's a squared value for tan. Therefore, I should be taking under root on both the sides. So this becomes tan theta, which equals plus minus square root of 0.5. And in this case, if I go for tan theta, this becomes plus minus square root of negative 1, which is not possible. So I will only be left here with the two positive and negative values for 0.5 and tan theta, which is equals to positive and negative 0.5. That means if I just have my quadrants here. So first I should be checking the domain. It was from 0 to 180 degrees. That's given in the question. So in the first and the second quadrant, I shall be having tan positive in the first quadrant and tan negative in the second quadrant. So here I can say it's theta, which is equals to tan inverse the basic angle, not theta. I should be getting the basic angle here. So the basic angle here is tan inverse square root of 0.5, and this basic angle, it comes out to be a 35.3 degrees. That means this value here is a 35.3 degrees. This value here is also a 35.3 degrees. Therefore, I can say that my theta values are 35.3 degrees and also 180 minus 35.3 degree, or I can say it's a 35.3 degrees and 144.7 degrees here. So these two then are going to be the solutions within the domain of 0 to 180 degrees. So the next question has been chosen from summer 21 and it's paper 1 variant 2, and it's question number 2, part B. So this is question number 2, part B, and I have chosen just this part B because part B was related to trigonometry. And the question says the curve y equals sine 2x minus 5x. Its y is equals to sine of 2x minus 5x, and this is reflected in the y-axis and then stretched by the scale factor 1 by 3 in the x direction. So these are the keywords that we should be knowing. So here write down the equation of the transformed curve. So this curve here, this needs to get transformed in 2 steps. Number 1, it's the reflection in the y-axis, and then it's the stretched by scale factor 1 by 3 in the x direction. So we should know that reflection here in the y-axis, reflection in the y-axis is always given as f of minus x. And we know that the stretch in x direction is given by f of x divided by b here. So this is how we give the the two transformations for reflection in y-axis and the stretch in the x direction. So if I go for the first transformation, which is reflection in the y-axis, then I should know here that this y here should be equal to sine of, because it's the reflection, this x should get multiplied by negative 2x, and for minus 5 of x, this should also get multiplied by a negative x here, leaving us with y, which is equals to sine of minus 2x and a positive 5x. Now, what we know about, another thing that we know about sine of, the identity for sine of minus x is that this can be written as minus sine of x. So I can also write this as y, which is equals to negative sine 2x and then a positive 5x. So this is for the first transformation, which is reflection in the y-axis. Now the second step here says it should be the stretch in the x direction. So I know that for the stretch, I should be dividing x by the stretch factor. The stretch factor here, the b value here, is given as a 1 by 3, meaning all the x values here, second transformation, I should be dividing the x values by 1 by 3. So here this becomes negative sine 6x and then a positive 15x. So this should be the transformed equation of the curve after the two transformations that we have been given here. So question 6 is from summer 2022 paper 1 variant 2, and it's question number 11 in the paper, and the question says the function f is given by f of x, which is equals to 4 cos to the power 4x plus cos square x minus k for 0 to 2 pi, where k is a constant. So given that k is a 3, find the exact solution of the equation for f of x equals a 0. So f of x equals a 0. Let's start solving this question. We are given f of x, which is equals to 4 cos to the power 4x plus cos square x and a minus k. So this equation should be equal to 0. So it's 4 cos of 4x plus cos square x minus k. This should be equal to 0, as it's given that f of x was equal to a 0. This was given in the question. So again, it's a disguised equation that we have here. So I can say it's m, which is equals to cos square x, and it's m square, which is equals to cos to the power 4x. So my quadratic equation becomes 4m square plus 4m and then a minus k, and the k value here is a 3, so I'm substituting k by 3. k value, it's given as a 3. This is also given in the question. So instead of k, I will be writing 3 here. So this then is equals to a 0. So it's a simple quadratic equation. We know it's a 4 times 3 giving us a 12. I can just factorize it directly and I can say it's 4m squared plus 12, and for 12 it should be a 4m minus 3m minus 3, which is equals to 0. It's 4m common. I'll be left here with m plus 1 minus 3 common. Again, it's an m plus 1, which is equals to 0. So it's 4m minus 3, and also it's an m plus 1, which then shall be equal to 0. So from here, I can say it's 4m minus 3 equals a 0 and m plus 1 equals a 0. Or m here will be equal to a 3 by 4, m here will be equal to a negative 1. M was equal to the cos square x, so I can say it's the cos square x, which is equals to a 3 by 4, or I can say it's cos of x, which is equals to, taking under root on both the sides, it's under root 3 divided by square root of 4, which gives us a 2. And here it's cos square x, which shall be equal to a negative 1. And if I take the square root for negative 1, then this is not possible. Square root of a negative number, this is not possible. So I should only be solving cos of x equals plus minus root 3 by 2. The given domain is from 0 to 2 pi. So if this is from 0 to 2 pi, then what I see here is that I have the cosine value, and with respect to this cosine value, it's from 0 to 2 pi. Therefore, I should be considering the quadrants where the cosine is a positive as well as a negative. It's positive in the first and the fourth quadrant, negative in the second and the third quadrant. Therefore, these are the angles and these are the quadrants that I need to find out. So what is going to be the basic angle? The basic angle here then is going to be a pi by 6. The basic angle here is going to be a pi by 6, and with respect to this pi by 6, I will be getting all my general angles. And here I can say that x values are pi by 6. In the second quadrant, it should be pi minus pi by 6. In the third quadrant, it should be pi plus pi by 6. And in the fourth quadrant, it should be 2 pi minus a pi by 6. So the x values here are going to be a pi by 6 and a 5 pi by 6 and then a 7 pi by 6, and then it should be an 11 pi by 6. The question has asked us to get the exact solutions of the equation. Therefore, I will not be solving for the pi values here, and this then is going to be the answer to this question. The second part of the question says use the quadratic formula. Now this is the hint that is given here. Use the quadratic formula to show that when k is greater than 5, the equation f of x equals 0 has no solution. So it should be having no solution, and we have to use the quadratic formula, and the function that is given is in terms of cos square x or cos to the power 4x. So when k is greater than 5, this is also is the condition that we should be having here. Quadratic formula is given as, we know that the quadratic formula is given as m, which is equals to a negative b plus minus under root b square minus 4ac divided by 2a. So m here is a cos of x. M here is a cos square x. So if m is a cos square x, then b is a negative 1 plus minus 1 minus 4 times negative k. I've just substituted a and c divided by 2 times a, and a here again is a 4. So if I solve it further, I can say it's a cos square x, which is equals to negative 1 plus minus under root 1 minus minus minus, it's a positive, and then I should be having a 16 here. Positive 16k divided by n 8. K should be greater than 5, so I will be substituting my k with a 5. 16 times 5 here divided by an 8. So it's going to be a cos square x, which is equals to negative 1 plus minus under root 1 plus a 90, 1 plus 80 divided by 8. Or I can say it's a cos square x, which is equals to negative 1 plus minus square root of 81 divided by 8. Or I can say it's a cos square x, which is equals to negative 1 plus 9 divided by 8 and a minus 1 minus 9 divided by 8 here. So because it's a cos square x, I have 8 by 8 and also a negative 10 by 8. So cos of x here, cos square x here shall be equal to a 1 and a negative 10 by 8. So what I have observed here is that if I take the square root, then it's going to be a cos of x, which is equals to plus minus 1. And for negative 10 by 8, obviously for negative values, cosine is not possible. So I should be having the solution only for cos of x, which is equals to a plus and a minus 1. So this means that it's actually the range of cosine of x, which should be a plus and a minus 1. We have already said that it's minus 1 lesser or equal to cos of x, which should be lesser or equal to 1. So this means if this value becomes greater than 1 or it becomes less than 1, the cosine values here will not be possible. And this is what the question has asked us, that for k to be greater than 5, k to be greater than 5, it should be having no solution. So if just 5 is giving us the marginal values for cosine of x, then for all the values which are greater than 5, all the values for k which are greater than 5, there is no solution for cos of x which should be either greater than 1 or cos of x to be less than 1. So whenever r k is greater than 5, there is going to be no solution for cos of x to be greater than, because that will give us the values which are cos of x greater than 1 or cos of x which are less than a negative 1. So giving us no solution here because of the condition for cos of x to be within negative 1 till 1. So this is going to be the solution of this question, and we will be continuing the past paper questions in the second video. So let's end the video here and we'll see you in part 2 of past paper questions. Best wishes and Allah Hafiz.